नमस्ते सर।
हेलो।
नमस्ते सर।
हेलो।
हेलो।
Yes, yeah, I can hear. I can hear.
नमस्ते सर।
Namaste, namaste. We have started already, no? It's already 10:30, beyond 10:30, right?
It started, sir.
Yeah.
Bharat from NPTEL.
Hello, Mr. Santosh, you have come to interact with me, right? Hello.
यस सर।
Yeah, please tell me.
यस।
You are on mute, I think. Again, mute.
सर, today we know about, please describe your written exam pattern.
I am not able to hear you clearly. Audio is not clear. Can you
Okay.
please repeat? Yeah.
Uh, that's we know about written exam pattern.
Written as MCQs based upon the content which is there in the.
Okay.
Yes. It is basically to test your understanding rather than to qualify you for something. So, as I have explained, I've taken great pains to explain. The topic is meant to give you an introduction to the biological part with an engineering flavor. So, the idea is to make you prepared for your work. It is not that you do this course and you get qualified for something. It's the other way around. So, when you do this thing,
Oh,
whatever work you are doing on the engineering side is expected to become easier because you will have an understanding of what is happening.
right.
So the question paper is basically to test your understanding, not actually as a qualifying, in the sense that you're expected to know something which will be very basic, but it is not competitive in the sense that you pass it and you say that okay, I know everything or something like that. That's the idea.
Okay, sir.
How do you find the course?
And NPTEL and the SWAM platform.
Pardon, I didn't hear.
This course is founded and the SWAM portal.
I didn't get you. आप हिंदी में भी बोल सकते हैं, नो प्रॉब्लम.
ओके सर। एक्चुअली ये कोर्स मुझे स्वयं प्लेटफॉर्म से मिला है, एनपीटीएल के थ्रू।
I don't know.
और इसके
Yeah, please. I'm not able to make out the audio clearly. There's a lot of
ओके
disturbance in the background.
हाँ, अब आवाज जा रही है सर क्लियर?
हाँ,
क्लियर वॉइस आ रही है?
क्लियर. हाँ, बोलिए 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 बोलिए.
हाँ,
थोड़ा
ये मुझे
जोर से बोलिए.
हाँ, स्वयं प्लेटफॉर्म से मिला है मुझे ये कोर्स। और एक्चुअली बेसिक पर्पस मुझे इसका बेसिक पर्पस है मशीन
आप क्या
लर्निंग और
करते हैं?
आर्टिफिशियल। वैसे मैं इंजीनियर,
ओके, कौन से सब्जेक्ट में?
इलेक्ट्रॉनिक।
इलेक्ट्रॉनिक्स. ओके, ठीक. जब मैंने ये कोर्स बनाया, मैंने सोचा बहुत तरह के इंजीनियर लोग हैं जो ये न्यूरल वगैरह वगैरह करते हैं पर जानते नहीं कि उसका बैकग्राउंड क्या होता है और किस लिए करते हैं और क्या उसका महत्व होता है। तो मेरा ये अटेम्प्ट था कि आपको, आप जैसे इंजीनियर्स को ये समझाना कि आपका जो काम है उसमें क्या बैकग्राउंड होता है, क्या क्या फाउंडेशन क्या होना चाहिए, वो
राइट
मकसद था।
राइट सर।
Okay.
सर वैसे इस कोर्स में मुझे बहुत कुछ सीखने को मिला है, और बेसिकली मेरा वैसे मैंने बैचलर डिग्री मैंने साइंस से ही किया, तो
Okay.
ये मेरे लिए बहुत हेल्पफुल रहा है।
Okay.
और
Thank you.
आगे भी मेरे लिए मशीन लर्निंग और एआई की केस में मुझे भी बहुत हेल्पफुल रहेगा ये।
Okay. Okay.
सर
Yeah. Hello. Yes.
हाँ हाँ, ह्यूमन बैलेंस सिस्टम थोड़ा सा
Hmm?
डिस्क्राइब कर दीजिए। ह्यूमन ह्यूमन बैलेंस सिस्टम।
Comment. Please type. मुझको audio is really bad. I'm not able to hear properly.
ओके ओके ओके।
It may be from my side also. I'm not blaming you. I should have taken a headphone. I'm not. I don't have a headphone here. Sorry for that. Please type in the query box. I'll reply. I'll message back or explain. See, balance is it is there are, okay. I think I've explained to you the human reflexes. Okay, so each reflex is like a stack. Okay, you got the monosynaptic reflex, and then you've got several kinds of reflexes. Now, I've explained to you coordination. So they are all something like a stack of logic frameworks which are built biologically. So you got monosynaptic reflex, polysynaptic reflex. Below the reflex, you have got motor and sensory parts. So as you go higher, there is this entity called as writing reflex. So you can check for RIGHTI reflex. So this is a reflex which is implemented based upon the necessity of being upright. Or say in a four-legged animal, no, you put a four-legged animal, it will get its oriented to that particular position. So the writing reflex has several components. So one of the components is balance, the ability to maintain that posture when there is an opposing force to it. I think that is the easiest way to explain. So that is through three separate things. So one is through the ears. So the vestibular system contains of three semicircular canals. The three semicircular canals are responsible for dynamic motion. So when there is movement, the semicircular canals send signals based upon both the sets. So the gain between the two sets of signals is processed within the brain, and that gives you the information of what motion you are having. Now, there is also something called as utricle within the brain, which gives static information. So what is the position, whether the head is upright, whether the head is bent. Now, these are related to the head. Now, why I use the writing reflex in the beginning is because, okay, these systems are present only in the head. What about the rest of the body? So for the rest of the body, there is information coming from proprioception. Proprioception is the is the ability to track the joint position at any given point of time. So you have one vestibular system and another the proprioceptive system. So these are two sensory complementary systems. The data which comes from both of these are completely different. One is rotation data and movement data and static data. Proprioception is just relative motion between any two parts of the body. So the vestibular system is in the head, proprioception is in the rest of the body, meaning at every joint. Now, this in combination with visual signals is responsible for balance. So put it the other way around, you must have heard of patients with diabetes. So patients with diabetes and elderly, so they lose sensation in the legs. So that is why people have difficulty in walking. So though their cerebellar system, which is responsible for action, vestibular system and eyes are relatively normal, because the leg is not that great in acquiring signals, they develop these problems of balance. So each of these give complementary data. So the brain integrates them. Somewhere in my course, I have explained to you the concept of maps. So within the brain, there are various places where the whole body is represented. Now, this whole body is represented not as in some dot. What do you call it? It's not in a matrix form. It is in relation to the environment which is around, both in relation to oneself and in relation to the environment. So these maps get updated on a very regular basis. Of course, I don't think anybody knows what is the actual functioning of this map. We know that these maps exist. One place where we know very, very well is the motor cortex. Similar kinds of maps are there even in the cerebellum. And there is some map which I recollect is present in the hearing auditory processing areas. So a combination of these maps helps to maintain the balance. So it's a complex phenomenon. It is not, if you just ask, say, if you give a search for human balance system, you'd find only the cerebellum, you'd find only the proprioceptive system and sensation to be major components, but it is not just so simple. It's a layered architecture of several systems. And you must remember that position systems are present even in lower animals, starting from maybe even ants, no? So ants also walk upright, right? So you can turn an ant
Right.
and then Yeah. So over the period of millions of years, the system has evolved, and we continue to adopt the system, which is present even in ants, cat, mammals, etc. Hope that clears. Okay. Any further questions? Okay, that is complex. So it is not something which you can uh, speak directly. I've spent a lot of time explaining the auditory system, how the see the external ear contains all these apparatus of channeling sound to the inner part of the ear, inner part of the external ear. There you got the diaphragm, and that diaphragm mechanically, like in a speaker, uses ossicles. That is small bones. Now that is used basically as an amplification mechanism, because the ratio of the eardrum to something called as the round window is about, I forget the exact ratio. So some kind of amplification happens. Now subsequent to that, this sound wave travels within the structure called as the cochlea. I've explained the frequency uh, pattern. So that sound wave resonates with a specific part of the cochlear membrane, and that membrane in turn stimulates cells. The mechanism I've explained in detail. It's a full class. So that's how the each sound wave is split into its individual frequencies. So that's called as a tonotopic organization. So entirety of the sound spectrum is split into frequencies. Amplitude is based upon the amplitude of the that membrane, tectorial membrane, and that in turn is converted into electrical signals. So you've got amplification at the outside, and then you've got frequency splitting at the cochlea, and the frequency data is sent back to the brain for the processing. So that's in very short summary the mechanism of how sound data is converted into electrical information. There are certain things, say for example bilateral. So you got 2 ears, so that is helpful in not only in gaining information about sound, but also in positional localization. You're able to make out from which direction sound is coming. That is by the altered phase of signals acquired at both the ears. So that by that you can actually calculate. So there are complex mechanisms. There's something called red nucleus in the brain, which is supposed to help in this kind of localization, where exactly a sound is coming from. The auditory system serves both the purposes. One is acquisition and processing of information from sound. The other is localization of sound. Okay, any further questions? Should we wind up? It's already 10:55. Electronic system brain simulation. I didn't understand, please. You must be meaning brain stimulation via electrodes. Okay, so as of now, it is used for certain diseases. You must have heard of Parkinson's, in which you use deep brain stimulation, and there is pain syndromes for which you use electrodes in the spinal cord. So the mechanism is that you generate electrical fields. These electrical fields are responsible for causing changes in the surrounding neurons. So that depends upon the location at which these electrical signals are given. And by observation, we know that it works like that. So, for example, deep brain stimulation, we know that the subthalamic nucleus is responsible for causing the diseases, or rather, if you give stimulation to the subthalamic nucleus through some specific frequencies, it is possible to change the way of some movement disorders. So over a period of time, we have realized that you can stimulate and give some current, and that causes changes in the disease. So similarly, in pain, you give stimulation to the spinal cord. It has been observed that the perception of pain changes. So that's I think what you are meaning. It's a separate field in itself. There's a lot of theory. It's of course a medical specialty. I think you should completely switch over to medicine to understand these things better.
Okay.
Thank you. I think you are muted.
We can wait for few more minutes, sir. If there are
Okay,
more
fine.
participants, we can
Fine.
wait.
Okay, okay.
Can we wind up, sir?
Yes, please. Thank you.
Okay,
Thank you for